Alright everyone, welcome to part 2 of the video. What I want to talk about right now is from page, what have we got there? 390. And these ones. Okay. It says, in exercise 11 to 20, use a graphing utility to approximate solutions. So we did, in the other video we solved one of these by doing factoring. You have to change that double angle formula out and do it by factoring. So that's a very, very, very useful way to do it. Doing it by graphing, honestly, without Desmos, it's a pain. Even if you have a TI-85 or 83 or 82, it's good, but Desmos is a little bit easier. It's still a lot of work. Okay, so factoring is probably a faster way, but we have the technology and it's said to use it, so let's do it. Alright, so remember that equation. Sine of 2x minus sine of x equals 0. Okay, I'm going to pull this up. And I'm going to pull up Desmos here. And I love this new screen here. So nice. So large. My new laptop here. Let's go back to here. So sine of 2x minus sine of x equals 0. So how the hell do you graph that? Well, y equals sine of 2x minus sine of x. Whoa, that's a funky graph. That's kind of cool in its own right. Let's go ahead and project the mode. Okay, here we go. Okay. So wait, what was the equation? The equation was sine of 2x minus sine of x equals 0. Well, in order to graph it, we have to graph y equals. Okay, so you have to have y equals. Well, how do I check when it's equal to 0? Well, when it's equal to 0, let's go y equals 0. And y equals 0 is the same as the x-axis. That's that flat line that is the x-axis. So in other words, when you're saying, when does this equal 0, you're asking when does it cross the x-axis. Now this is super easy. Check this out. Blammo, 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 blammo. Okay, so they're all there. And a couple things, I can't explain to you right now why it's pi over 3. The only way to do that would be if we solve this by factoring. You would get these answers. The factoring, the way we did in the other video and what we did on the previous problems, example 1 in the book, it will solve and it'll get you some of these answers. But the thing goes on forever. This thing goes on forever. So technically you could be way out here, right there, or way out here, or right here. And you'll notice it's something over pi over 3, or it's a whole number pi. And you're going to find patterns like that. There it is, another pi over 3. And probably, come on. Nope, that's a pi over. Anyways, there's patterns there. And so one way is to graph it, but and that's very visual. That does help. You can see exactly where it crosses. But to explain why it's something pi over 3, you'd have to convert forms here. I cannot solve this thing right here in my head. There's absolutely no way. All right, let's do one more just to make sure we're clear on this. Next one, that's pretty much the same. Let's say 4 sine of x cosine of x. 4 sine of x cosine of x. 4 sine x cos x. There it is. Whoa. Well, it does not like that. Okay. It doesn't like, yeah, it wants parentheses around these, so around my x's. That looks better, and let's put it around there, and that'll probably look better. Alright, now it seems to understand it. Now, what we were looking for on here is we were looking for when does it equal 1. So our second equation would be equals 1. And again, that's a flat line. This time it's going through 1. What we're looking for is all these places where it crosses. Now, why is it 25 over 12 and 29 over 12? Can't tell you that. We'd have to change this. We'd have to do some. We'd have to change things around here. You have to change forms and use one of the other formats, or factor it. And so some of these are easier to do than others. But graphing is definitely easy. Okay, so graphing, you can definitely visually see it. Algebraically solving it, though, is definitely another good way, and you want to be able to be fluent in both methods. All right, thanks for watching. Let me know if you have any questions, and just drop me an email, and I'll catch you later.